Imagine you're browsing the internet, and a mesmerizing image catches your eye. It's unlike anything you've seen. An artistic interpretation of a city suspended in the clouds, colors blending seamlessly, a futuristic vision of nature and technology. As you marvel at the details, you learn that this captivating image wasn't created by a human artist, but by artificial intelligence. How did AI, a machine without emotions or sensory experiences, create such a stunning work of art? What is the magic behind this seemingly impossible feat? For many, AI-generated art feels like magic because the process happens so quickly and yields such compelling results. How does a machine translate human language into art? What does it mean for AI to understand a description and then create an image that matches it? Behind this seemingly mystical process lies an intricate web of algorithms, machine learning techniques, and neural networks that work together to turn a text prompt into an artwork. We're here to reveal how this technological magic works. The answer lies in the sophisticated machinery of AI algorithms that blend concepts from computer vision, natural language processing, and pattern recognition. The simple explanation is that AI image generators are powered by two core components. Neural networks. These brains of the AI learn from vast datasets, enabling them to recognize patterns and associations between images and text. Diffusion models. These models sculpt the final image by gradually adding and removing noise, a process that can be thought of as refining a rough sketch into a finished piece. In this journey, we'll explore these components in greater depth, peeling back the layers of complexity while keeping the explanations accessible and engaging. Our journey to understand AI image generation begins with the foundational technologies that enable machines to become artists. Like human creativity, AI image generation involves both learning and refining. As we unravel this process, we'll also dive into its broader implications and future possibilities, from generating personalized art to transforming industries like gaming and entertainment. At the heart of AI image generation lies a combination of powerful machine learning technologies, enabling machines to create visually coherent and even stunning artwork from a simple text prompt. To fully appreciate how this is achieved, we need to peel back the layers and explore the two foundational components that make this magic possible: neural networks and diffusion models. Alongside these, we'll examine the training process that teaches AI how to generate these images and explore how text inputs are transformed into visuals. Neural networks, the AI brain that learns. Neural networks are one of the fundamental technologies driving AI's ability to generate images. While the name may evoke complex, brain-like structures, the concept behind neural networks is based on relatively simple principles. Neural networks are inspired by the human brain, mimicking how our neurons connect and fire to process information. However, unlike the organic brain, neural networks are made up of artificial neurons organized into layers. Each layer is interconnected with the next, and these connections enable the network to learn from data. The architecture of a neural network. To understand how a neural network works, let's break down its architecture. A typical neural network consists of three main types of layers. Input layer. This is the first layer, where the data is introduced into the network. In the case of AI image generation, the input could be a text prompt such as "a golden sunset over mountains." Hidden layers. Between the input and output layers, there are one or more hidden layers where the actual processing happens. These hidden layers contain thousands or even millions of interconnected neurons, each performing calculations and adjusting based on the data they receive. These layers help the AI learn how certain words, patterns, and objects relate to visual representations. Output layer. The output layer provides the final result of the network's processing. For an AI image generator, this could be the generation of a rough image that corresponds to the input text. Each neuron in a neural network has a numerical value called a weight that adjusts during the training process. These weights control how strongly one neuron influences another. Over time, the network learns to adjust these weights to minimize errors in the output, a process known as training. Learning from data neural networks rely on vast amounts of data to learn how to generate images from text. This data usually comes in the form of image-text pairs. For example, the AI might be fed thousands of images of sunsets along with their corresponding descriptions, e.g., a golden sunset over a calm ocean. By seeing many examples, the AI learns to recognize the patterns, colors, and shapes that typically appear in sunset images. This learning process is powered by backpropagation, a technique that allows the AI to adjust its weights by analyzing errors in its predictions. Each time the AI generates an image that doesn't perfectly match the text prompt, backpropagation helps the network identify where it went wrong and adjust the relevant weights accordingly. This gradual adjustment allows the neural network to improve its performance over time. Pattern recognition and feature extraction. One of the key strengths of neural networks is their ability to recognize patterns in data. When the AI is trained on large datasets of image-text pairs, it learns not only to recognize individual objects, like cat or tree, but also to understand higher-level features, such as artistic styles, lighting, and color schemes. For example, consider the phrase, "a cat sitting on a windowsill, bathed in golden light." The AI doesn't just recognize cat and windowsill as separate objects. It also learns how to blend them in a way that makes visual sense. For instance, ensuring the light hits the cat in a realistic way based on the direction of the window. Neural networks extract these features through what's called convolutional layers in a process known as feature extraction. These layers allow the AI to identify shapes, textures, and patterns in images, helping it understand how different elements fit together to form a coherent visual. Language understanding, bridging text and image. One of the remarkable aspects of neural networks in AI image generation is their ability to understand language in a visual context. This involves not just recognizing words but understanding their relationships and translating abstract ideas into concrete visual elements. For instance, if the text input is a surreal landscape with floating islands, the AI must interpret the meaning of surreal and floating islands in a way that makes sense visually. The neural network learns to associate certain descriptive words like surreal with artistic styles that emphasize dreamlike or fantastical elements. To achieve this, AI models often use natural language processing (NLP) techniques, which help the AI grasp the meaning of words and phrases. These techniques allow the AI to break down complex text descriptions into visual elements that it can represent. Diffusion models, sculpting images from noise. While neural networks help the AI learn from data, diffusion models play a critical role in the actual generation of images. They are responsible for refining and creating detailed images based on the patterns learned by the neural network. In many ways, diffusion models are like sculptors, gradually refining a rough block of material into a finished piece of art. How diffusion models work. Diffusion models work through a process of adding and removing noise. This may seem counterintuitive at first, but it's actually a powerful way to generate high-quality images. Here's how it works. Starting with noise. The process begins by taking an image and adding random noise to it. Imagine starting with a clear image, like a photo of a landscape, and gradually adding static or distortion until the image becomes completely unrecognizable, learning to reverse the noise. The AI is then trained to reverse this process, to remove the noise and return the image to its original form. By learning how to denoise images, the AI becomes capable of understanding how visual elements are constructed, generating from scratch. Once the AI has mastered the process of denoising images, it can generate images from scratch. Instead of starting with a real image and adding noise, the AI starts with pure noise and uses the diffusion process to sculpt a brand new image. The AI removes noise in a way that gradually reveals the visual features described by the text prompt. This process can be compared to an artist starting with a blank canvas and gradually refining it, stroke by stroke, until the final image emerges. The role of latent diffusion models. One of the most advanced forms of diffusion models used in AI image generation today is the latent diffusion model. This model operates in a latent space, where high-dimensional data, like images, is compressed into a lower-dimensional representation. Working in this space makes it easier and more efficient for the AI to manipulate and generate new images. In a latent diffusion model, the AI first compresses the image data into a latent space, where it applies the diffusion process. By doing so, it can create complex and detailed images with greater efficiency, since working in a lower dimensional space reduces the computational load. Once the image is generated, the AI decodes it back into the original high-dimensional space, producing the final visual output. The training process. Teaching AI to generate images. Training an AI to generate images is a complex and resource-intensive process. It involves feeding the AI vast amounts of data and allowing it to learn from examples over time. Let's break down the key steps in the training process. Step 1. Data collection. The first step in training an AI image generator is to collect large datasets of image-text pairs. These datasets typically include millions of images, each labeled with a corresponding text description. Commonly used datasets include ImageNet, a large visual database designed for use in visual object recognition software research. COCO, Common Objects in Context, a dataset that provides labeled images of everyday objects in real-world settings, with detailed captions describing each image. These datasets serve as the foundation for the AI's learning process, giving it a wide variety of visual and textual examples to learn from. Step 2. Pre-processing. Before feeding the data into the AI, the images and text descriptions are pre-processed to ensure they are consistent and ready for analysis. Images are often resized or adjusted to a standard format, while text is tokenized, broken down into individual words or subwords that the AI can interpret. Step 3. Training the neural network. The neural network is then trained on this data through a process called supervised learning. In this process, the AI is shown image-text pairs and tasked with learning the relationships between them. For example, if the AI sees the text "a cat sitting on a windowsill," it learns to associate this description with images of cats, windowsills, and the spatial relationships between them. Over time, the AI becomes more accurate in predicting how different text prompts should be visually represented. Step 4. Refining with diffusion models. Once the neural network has learned to interpret text and associate it with visual elements, the diffusion model takes over to refine the image generation process. The AI learns to generate images by starting with noise and progressively removing it, sculpting the final image in line with the text prompt. This step often involves many iterations, with the AI continuously adjusting its weights and fine-tuning its parameters to improve the quality of the generated images. Step 5. Fine-tuning and testing. After the initial training process is complete, the AI undergoes fine-tuning, where it is further trained on specific tasks or styles. For example, if the goal is to generate hyper-realistic images, the AI might be fine-tuned on a dataset of high-resolution photos. Alternatively, if the goal is to create artistic interpretations, the AI may be fine-tuned on a dataset of artwork. The AI is then tested on new text prompts to evaluate its performance. If the generated images are high quality and accurately reflect the prompts, the model is considered ready for deployment. Text-to-image generation, step-by-step breakdown. Now that we understand the key components of neural networks and diffusion models, let's explore how a simple text prompt is transformed into a visual masterpiece. Here's a step-by-step breakdown of the process. Text encoding. The user provides a text prompt, such as a futuristic city with flying cars. The AI encodes this text into a mathematical representation that captures the meaning of the words, mapping text to visual concepts. The AI uses its neural network to map the encoded text to visual concepts. For example, it identifies futuristic as a concept that might involve sleek, metallic designs and flying cars as an object to be included in the image, generating a rough image. Using the diffusion model, the AI generates a rough image by starting with noise and gradually sculpting it into a visual representation of the prompt. At this stage, the image may be simple and abstract, but it captures the general structure of the scene. Refining the image. The AI continues to refine the image by adding details, textures, and colors. This process involves multiple iterations, with each step bringing the image closer to a polished final result. Final output. The final output is a fully realized image that matches the text prompt. The AI has transformed the user's words into a unique visual creation, ready to be used in art, design, marketing, or entertainment. AI image generation is a technological marvel that combines cutting-edge machine learning techniques with artistic creativity. By understanding the core components of neural networks and diffusion models, we gain insight into how AI can transform simple text descriptions into stunning visual representations. As this technology continues to evolve, it is reshaping industries, opening up new possibilities for creativity, and sparking our imaginations about what the future holds. Whether you're an artist, a designer, a marketer, or simply someone fascinated by technology, the world of AI-generated images offers endless opportunities to explore and innovate. The magic is real, and it's powered by some of the most sophisticated algorithms in the world.